Hi everyone, we are Team 2, and this is our presentation on the Cadet Chapel. In our previous presentation, we mentioned that the roof part of the Cadet Chapel and the building part distribute the load separately. We also discussed how the frame and the load of the building part are transmitted to the ground. Starting from this session, we will examine the roof part and its foundation. The roof structure is primarily made of steel and its load is transmitted down the slope. Reflecting these characteristics, we have constructed a foundation specifically for the roof. The roof part consists of 17 repetitions of the same shaped spire, and we will take one of them for examination. These spires are grounded at a particular angle, supported by a base of such shape through steel hinges. Then, these support bases transmit the load deeply into the ground through embedded piers, reaching the rebar placement. This way, the heavy steel frame's load can be transmitted vertically into the ground. This is the overall load transmission method of the roof part. Now, we will divide it into the pier section, support base section, and the frame section to provide detailed construction explanations for each part and examine how they're intricately interconnected. Just like any typical structure, the construction of the roof part's foundation begins with the most fundamental element of the building, the rebar. We erected reinforcing bars to support the structure and surrounded them with rebar rings for additional stability. The top of the pier is shaped into a trapezoidal form known as coping. This coping effectively transfers the load applied over a wide area to the column beneath it. Do you see the reinforcing bars protruding above the reinforced concrete? These are intended to form a connection with the support base, which I will explain next. The role of the support base is to transfer the load from the steel frame to the column. To do this, it's necessary to alter the direction of the force. For this reason, the support base is constructed diagonally. Similarly, the rebars rising from the RCC pier were placed diagonally, and through formwork, a support base made out of reinforced concrete was created. An important point to note here is that when we consider the diagonal loads in terms of vertical and horizontal components, the vertical forces are transferred through the RCC pier into the rebar placement, while the horizontal forces are transmitted through the ground to the retaining walls we constructed earlier. Now let's talk about the hinge. In order to determine the best type of connection between the support base and the steel frame, it's crucial to consider the characteristics of the structure. Because these frames were made out of steel, they will expand and contract depending on the temperature changes. In a situation where only one side of the structure is exposed to the sun and both ends are rigidly fixed to the ground, the frame will deform due to thermal expansion. And to prevent this disaster, we have chosen to use a hinge support. With the hinge support, if one side expands, the other side can adjust accordingly, and it will return to its original position as the heat dissipates. Now let's construct the hinge support. We'll create a steel hinge base that matches the end of the support base and use bolts to secure them together. In order to connect the frame to the hinge, the end of the frame needs to be shaped into a ring. This ring is then fitted into the support and secured with bolts, completing the hinge support installation. Now with this setup, we are ready to withstand the load of the roof part. Next, let's explore how the tetrahedral shaped steel frame of the Cadet Chapel was constructed. The steel frame consists of repeated arrangements of 3 modules: the lower section, upper section, and connecting parts. Each steel frame was pre-manufactured by a steel company in Missouri, located in the eastern part of Colorado, in specialized facilities known for producing high-grade steel. The 6-inch and 4-inch diameter steel pipes used as the primary and secondary structural members were sourced from steel mills located in regions renowned for their steel production. This ensured access to high-quality materials that met the stringent requirements for strength and durability necessary for the chapel's design. The steel underwent a meticulous process of cutting, shaping, and welding, carried out in controlled industrial environments to achieve the exact geometrical configurations needed. Once manufactured, the 100 steel tetrahedrons were transported to the construction site via rail to the nearest rail depot. This transportation strategy was critical given the size and weight of the tetrahedrons, each measuring 75 feet in length and weighing 5 tons. Rail transport provided an efficient means of moving these large components over long distances, minimizing the risk of damage and ensuring timely delivery. From the rail depot, the components were transferred again by trucks, equipped to handle heavy loads, for the final leg of the journey to the USAFA grounds. The logistics of road transport were carefully coordinated to avoid any disruptions and to comply with road safety regulations, considering the oversized nature of the loads. Upon arrival at the site, cranes were used to lift and accurately place each tetrahedron. Temporary supports were installed and beams to be connected at the ends of the modules were put in place. When cranes brought the tetrahedrons near, people both below and above performed welding and bolting to secure the tetrahedron with the beams and hinges. The support base was fixed using bolts as previously described. The initial assembly involved bolting to temporarily secure the pieces, allowing for adjustments and alignments before final welding was completed, to permanently fix the structure in place. This process was replicated on both sides for all 17 units. And after installing all modules of the lower section, ladders were attached so that workers could climb and install beams in the same manner. The connecting modules were then installed between two beams. And then, the upper section modules were installed on both sides. Finally, welding both sides of the upper section modules completed the steel frame of the cadet chapel. With the building's frame now complete, the next steps involve applying aluminum and stained glass for the finishing touches, along with additional installations like waterproofing facilities. Next week, we'll explore the exterior finishes and the other facilities.